Law of cosines. As you see here at the top, we have the theorem of law of cosines. I will encourage you to write these down or have them to the side as you're working on this section. And if a triangle ABC is the oblique triangle with sides A, B, C, right? Sides A, B, C, then we have angles of theta, beta, and gamma. And here is some really good visual graphs to show you examples of triangles using the cosine. And if you notice, it's about the x-axis, which makes sense because in an ordered pair, it's cosine comma sine, where cosine represents the x value and sine represents the y values. Now the length of a chord, if you see here, we have a formula of a length of a chord. Has side A subtends a central angle, theta, and a circle of a radius, r. Then we get this formula. So let's solve this first example. In this first example, we have a triangle with side A, B, and C given. And if you notice, there's no angles given. We don't have gamma, we don't have alpha or beta. So we're going to have to do some work here. Doing this, we can go back and grab one of those theorems above for cosine and solve for one of the angles. So let's start with, let's just do the a squared equals b squared plus c squared minus 2bc cosine of alpha. And just a little helpful reminder, if we are setting A equals to that theorem, then we know it's going to have its angle that's across from it, which is theta. So if we was doing B, it would be beta. If we was doing C, it would be gamma. So just a helpful hint on that. So we're wanting alpha here. In order to get alpha by itself, I need to start cleaning up the side. And what I notice on the side, I have b squared plus c squared. So if I subtract them from both sides, and guys, some of you may want to plug in first, put them together, then do it. You can do that as well. But I'm just going to go ahead and do it while it's still in the variable terms. So now I got a squared minus b squared minus c squared is equal to negative 2bc cosine of alpha. Well, the coefficient on cosine alpha needs to be a positive 1. And if you notice, it's a negative 2bc. So if I divide by that negative 2bc, negative divides negative positive, 2 goes in itself once, b goes in itself once, c goes in itself once. And that's what we want. It's going to leave us with that cosine of alpha. All right, I'm going to just rewrite this a little neater over here. So, and I'm going to bring the cosine of alpha out front. So now I got a squared minus b squared minus c squared divided by that negative 2bc. All right, I need alpha, not the cosine of alpha. So I am going to take its inverse. So it gives me alpha is equal to the cosine inverse of that fraction. And now I want to start plugging in everything I know. All right. I know that A is 23.4 and we're going to square it, minus that B, which is 12.8, and square it, minus C, which is 16.1, and we're going to square it. And then we're going to divide that by the negative 2 times my B, which is 12.8, times my C, which is 16.1. And you can type it all in your calculator. Some of you may have to use a lot of parentheses. Some of you may want to clean up and get the numerator together and then the denominator and then divide. I'll go ahead and do that just so that way you'll have it to compare to your answers to make sure that you got the right one. Was you gonna say something?
I'm turning it on.
I ain't hot, but if you're gonna stay in here, you might want to turn it on. I don't know why I'm writing because I ain't recording. Okay, I'm gonna record soon as you shut the door. So I'm typing in my calculator, the numerator, 23.4 squared minus the 12.8 squared minus the 16.1 squared. And I get my pen, there we go. I get 124.51. And if you're not sure, you can always double check your answer. I'm going to divide that by. So now I got -2 times that 12.8 times 16.1. So I get a negative, and you can bring the negative out front of that fraction, 412.16. And now I'm going to say cosine inverse, and I'm going to do my fraction. And don't forget your negative. So I got 124.51 divided by 412.16. And we round to the nearest tenths. So I got 107.6 degrees for the alpha. So 107.6 degrees. All right. So I found alpha. Now I'm going to find beta next. Okay, let's see if I have enough room on my paper. Okay, so I don't. What I'm going to do is erase this, guys. Let me erase all of this. Now that I've erased all of this, let's solve for our next angle. Okay, well, when I solve for the next angle, I only have one angle and I have all my sides. So what I want to do is use the law of sines, okay, to find the other one. And I know what I want to solve for next is going to be my beta. So I'm going to do sine beta over b is equal to sine of alpha over a. And let's solve for a sine of beta. So I'm going to multiply both sides by the denominator of the sine beta. And now I have sine beta is equal to b sine alpha over a. And now I want beta, not sine of beta. So I'm going to take its inverse. And when I take the inverse, I got beta is equal to sine inverse b sine alpha over a. And now I'm just going to plug in what I know. Sine inverse b is 12.8. Sine alpha 107.6 degrees for alpha divided by a, which is 23.4. All right, type it in my calculator and round to the nearest tenth. I got 31.4 degrees. So that's beta. Now that I know two angles, I can say, okay, let's solve for gamma. So solving for gamma, we can set it up. We all know that alpha plus beta plus gamma equals 180 degrees. Well, we can subtract the alpha, subtract the beta from both sides. And this is what I get. And I'm going to plug in for alpha, gamma, and I get 41 degrees for gamma. And that is what we do. So next, let's do example 2. As you notice in example 2, we're giving two sides and an angle. And we want to solve for the other pieces. So we got side A, we got side A, and we got side C, and we got beta. So that means we're left solving alpha, gamma, and B. So let's do this. What I could do is, since we're solving for B, we can get the theorem for cosine of B squared is equal to A squared plus C squared minus 2AC cosine of beta. And let's solve for it. Now, let's just solve for it. We'll do these in steps. Some people are going to want to skip around. Just be careful, find your consistency. So what I want to do is just plug in what I know. A is 9.4 squared minus 1.9 squared minus, or excuse me, 9.4 squared plus 1.9 squared minus the 2 times that A times that C, all times cosine of beta. All right, so now that I plugged in everything, we're going to get our calculator and clean this up. 9.4 squared plus that 1.9 squared. So I get 91.97 minus 2 times 9.4 times 1.9 is 35.72 cosine of 22.3 degrees. Now, if you want to, you can type it all in your calculator like this: 91.97 minus 2 times, not 2, excuse me, 35.72 cosine 22.3. And I'm not going to round right now. Do not round. You get 58.919, 921. $50886. And what I have here is B squared, and I want B. So to undo a square, we're going to take square root, Now, whenever you're talking about square roots, we know it's even, so we get a plus or minus. However, we don't want a negative side length, right? So we're not worried about the negative of it. So now I have B is equal to, and I took the square root of that number. So square root of 58.921, 50886. And I'm going to round to the nearest tenths, and it gives me 7.7. So now I know B is 7.7. Now we're going to take the law of cosines, because we need to find, except not cosines, of sines, because now we have only one angle and we need to find another angle. So I'm going to solve for, you can solve for alpha or we can solve for gamma. Let's solve for gamma first. So sine of gamma over C is equal to, and the reason why gamma is a good pick is because we know what C is. And so we're going to set it equal to sine of beta, and that's the angle we know, divided by B. Well, we just found B, so this works out great. All right. And another clue that we needed to do this cosine rule was that we had beta, but we didn't know B, and they go together, right? We have alpha, but we have A, but we didn't have alpha, right? And they go together, and so forth. So this is a good indication of using this. Now I'm going to solve for gamma. In order to do that, I need to multiply both sides by the denominator of gamma, which is multiplying by C. So now I got sine of gamma is equal to C sine beta divided by B. And since I want gamma, I'm going to take its inverse, so I can get gamma. Whoops, I wrote alpha. Let's erase that and put gamma down. There we go. Gamma is equal to sine inverse of C times sine beta over B. And now I'm going to plug in what I know. Okay, so C is 1.9. And then sine beta, beta is 22.3 degrees over B. We just found that 7.7. We type that in our calculator, round to the nearest tenth, and we get 5.4 degrees. Awesome, we're almost done. Now I need the last angle. So we know that alpha plus beta plus gamma equals 180 degrees. So to find alpha, I can subtract the beta and gamma from both sides. And now that I've done that, I'm gonna, let me come over here. Let me make a box where it's a little bit neater. All right, so over here on this other side, I'm going to solve for my alpha. So I got alpha is equal to 180 degrees minus my beta minus my gamma. Let's plug in what we know for beta. Beta is 22.3 degrees. And then gamma, we just solved it, gave us 5.4 degrees. And then you can use your calculator or your scratch piece of paper, and we're going to find that rounded to the nearest tenth, our alpha is 152.3 degrees. Now we found everything and we're good. So we know all the lengths and we know all the sides of this triangle. Okay, so let's do example 3. So in example 3, we have a forest ranger that is 175 feet. In the diagram here, I actually changed the number, so you are going to see here in, oh, I didn't change it. I meant to change the numbers to 175, but instead we're going to do 169 feet. So in the diagram, you can see that the forest ranger is 169 feet above the ground in this tower right here. And when she spots an angry grizzly bear east of the tower with an angle of depression of 10 degrees. So here's our angry bear. And then as in the figure, so southeast of that tower, she spots a hiker at an angle of 15 degrees. So we're wanting to find the distance between the hiker and the angry bear. So we're gonna have to do a little bit of work in order to figure that one out. So I wanted to do a little refresher, a reminder on our sine, cosine, and tangent. So we know that sine of an angle is opposite over hypotenuse. Cosine of an angle is adjacent over hypotenuse. A tangent is of an angle is opposite over adjacent. Okay, so that's just a little reminder. This will help you figure this out. So first we're going to find the unknown sides of the triangle and create the distance between the tire and the hiker. So, and then we're going to go find the distance between the tire and the bear. And then once we find those, then we can find the distance between the hiker and the bear. So in order to find all these, we're going to follow these rules. Well, what I noticed is that how it is set up, we are going to use the tangent one, and I will get back to this here in a minute, but we'll use the tangent. So to find the distance between the tire and the hiker, first we're going to find the angle indicated by the arrow here that's on this picture here, this diagram. And then we're going to notice that the angle is complement to the angle of the depression. So when we notice that from the tire to the hiker, we have a complementary angle or depression of 15 degrees. So what do I have going on here? I have a 90-degree angle. So I'm going to subtract that 15 degrees from it, and it gives me 75 degrees. Okay. So if I was to draw this out, what do I have here? And it's not perfect, or I'd have a better angle. This right here, this angle right here is that 15 degrees. Okay. And then this one here is at 75 degrees. All right. And they are, from here is the tire, from here is the hiker, 169 feet. So we're going to use this trigonometry function in the right triangle to find the distance from the tire to the hiker. Notice that the angle adjacent to the height of the tire is known, and the side opposite of this angle is the desired distance. Therefore, the tangent formula to find the distance of the tire to the hiker is the best option here. So we're going to calculate the distance from it. So I'm just going to rewrite the tangent, and I'm going to say distance, and I'm going to put TH, tire, to distance from tire hiker. That's going to be my notation, and it's going to be divided by the height. All right. Well, we know the angle, right? So we know it's tangent of 75 degrees. We don't know the distance, so I'm going to leave it in this notation. We do know the height, which is 169 feet. So in order to solve for DTH, I need to multiply both sides by this denominator to undo the fraction. And now I have, and I'm going to bring the DTH out front. So I got 169 tangent, 75 degrees. And we're going to type this in our calculator round to the nearest tenth. I got 653.1 feet. Okay, so that's good. Now I'm going to draw and separate my page so that way we can do our next one. So we know the distance from the tire to the hiker is 653 degrees. Now we're going to calculate the distance from the tire to the bear. Notice the difference between finding the distance and finding the distance between the tire and the hiker is the angle depression of 10 degrees instead of the 15, okay? So and it was given to us here when you go read this, when you read this here. See, it's given to us here. All right. When you read the application problem. So let's look at it. What we got going on, we are going to, let's label this the tire to the bear. We got the 90-degree angle going on. We're going to subtract the 10 degrees, which gives me 80 degrees. So again, if we was to draw this out, we got the tire here, we got the bear actually over here, right? And that height is still 169 feet. And we got an angle of 10 degrees. We got the 80 degrees. All right. Actually, it would be flipped. Yeah, no, that looks right. That's right. Because if you was to look at this picture here, can you see it? Right here, me drawing on it. There we go. That's what we're looking at here. All right. We're going to calculate the distance. So I'm going to take the tangent of the angle and the distance. I'm going to say TB over the height. And we're going to solve for TB. So I'm going to multiply both sides by the denominator to get the distance by itself. And undo the fraction. So I'm going to plug in what I know for my height. It's 169 feet. And our angle is 80 degrees. And when we type it in our calculator around to the nearest tenth, I get 992.5 feet. Okay, so now what we need to do is we're going to, it's always good to draw. If it helps you draw a picture, determine, and when you're given one, if you can label it and separate it and draw your picture on top of it, it will help you as well. Now, we're going to let the distance be A and the angle opposite be alpha. That is the angle between east and southeast. All right, so whenever we're drawing this and labeling this triangle on this picture, trying to find the, because next we're wanting to solve for the distance between the bear and the person, the hiker. I'm going to take the 90 degrees and I'm going to divide it by 2 because we are splitting it in half. And this gives me 45 degrees for my alpha. Okay. Now that we did that, find the length of it, and we're going to use the cosine. Since we know we labeled it alpha, we're going to use the theorem of a squared equals b squared plus c squared minus 2bc cosine of alpha. So a squared is equal to, and we know what b is. B is going to be the, it's going to be, and if you need to label, I would. B can be the distance of tire to hiker, and C is the distance from tire to bear. So we're going to plug it in. 653.1 squared plus the 992.5 squared minus 2 times that B. I didn't give myself enough writing room. So I'm going to bring it down underneath it just so it wouldn't be too messy. And we said alpha is 45 degrees. And we're going to type this in our calculator. It's going to give us or this long number 49,000.154. And we got to undo that root. So we're going to take the square root of both sides. And when I take the square root of both sides, I get, and let's round to the nearest tens, I get 703.5. So the distance between the hiker and the bear is 703.5 feet.